Algebra 1, Common Core, Unit 2, Section 2, zero and negative exponents. So the previous lesson we talked about some basic exponent properties where we multiply a common base, we add the exponent, exponent raised by an exponent is multiplied, divide a common base, you subtract. Here we're going to learn about a couple of special exponents. So first, what happens when you have a zero exponent, something raised to the zero power? Well, the rule is that anything raised to the zero power, well, anything besides zero, zero raised to zero, zero is kind of weird, but anyways, any non-zero expression, whether it's a number, a variable, anything raised to the zero equals 1. That's it. So no matter how complicated the base is, if it's raised to the zero, it just equals 1. Where you have to be careful is when you get into parentheses. So let's look at a couple of these examples down here. X to the 0 is 1. 5 to the 0 is 1. Negative 4 to the 0 is 1. Anything to the 0, any non-zero number, variable, expression, anything raised to the 0 equals 1. You know, even a negative raised to the 0 equals 1. Non-negative 1. A negative raised to 0 is positive 1. Everything raised to the 0 is 1. When we get into negatives, this is where it's a little strange here, something like this, because you remember back, the difference between, negative 3 in parentheses squared is positive 9, but negative 3 without parentheses squared is negative 9. And it's because the base doesn't know that that negative is attached or not kind of thing. So this type of question right here it's kind of almost like negative and then 4 raised to the 0 because there's not parentheses around it like we do here. And so 4 to the 0 is 1, and then the negative makes it negative 1. So here's where you get a negative 1, is if a negative base is not in parentheses. Here the whole base 5x is raised to the 0, so it equals 1. But this is a little bit different. Again, what is being raised to the 0 power? Here both 5 and x were, because they were in parentheses raised to the 0 power. Here, only x is being raised to the 0 power. And this is really 5, when things are up against each other like that, that's 5 times x to the 0. A coefficient is being multiplied by its variable. So 5x is 5 times x. So 5 times x to the 0 is really 5 times 1. X to the 0 is 1, which equals 5. This does not equal 5 because 5 is also being raised to the 0. 5 to the 0 is 1. X to the 0 is 1. And together they multiply. 1 times 1 is 1. So if the whole thing is in parentheses to the 0, the whole thing is 1. But if only a piece is being raised to that 0, that piece becomes a times 1. All right, so that's zero exponents. Really just got to be careful with parentheses. Most of the time it's 1, but sometimes you'll see something like this where that piece is 1 times its coefficient. Negative exponents are a little bit more complicated. Negative exponents cause reciprocals. And reciprocal is when you flip a fraction upside down. So like if you have the fraction 2 over 3, its reciprocal would be 3 over 2. You don't change signs of anything. It's not like it goes from positive to negative and stuff like that. You'll see that a little bit in geometry with perpendicular slopes, but not in Algebra 1. So reciprocals are just when you flip a fraction upside down. A over B becomes B over A. That's it. And everything, even if it doesn't look like a fraction, can be made a fraction. Like the number 5 can be made a fraction by putting it over 1. So its reciprocal is 1 over 5. So a negative exponent causes a reciprocal base. And so whatever the base is, you reciprocal the base, and then the exponent goes back to being a normal positive exponent. Like here, I have x over y to the negative n. Well, if I flip the base, if I reciprocal the base, instead of x over y, y over x, the exponent goes from negative to positive. And that's really what you're trying to do. Anytime you see a negative exponent, is you want to turn it into a positive exponent and then deal with it from there. All right, so here, the base is x. The reciprocal of x, which is really x over 1, the reciprocal of x over 1 is 1 over x. And that is now being raised to a positive 2. Right? Once I reciprocal the base, I change the exponent from negative to positive. And then whenever you have a fraction with exponents, you could apply it to the top and bottom. So it's really 1 to the second is 1, and x to the second is x squared. Here I have a negative 3 exponent, so I reciprocal the base, and x over 1 is going to be, 1 over x, sorry, is going to become x over 1, but you don't always have to write over 1, and it's going to be raised to the positive third. All right, again, here the parentheses are really important because notice that this 5 is not in parentheses with being raised to that negative exponent there. So the 5, let's just keep that aside for a minute. 5 times x to the negative fourth. X to the negative fourth becomes 1 over x to the fourth. 1 over x to the positive fourth. Sometimes people, when they flip the base or flip the reciprocal, flip the base is doing a reciprocal. They forget to change the exponent from negative to positive. So sometimes people will write it as, 1 over x to the negative fourth. Well, no, that's, reciprocaling the base, flipping the base, the whole purpose is to change the exponent to a positive exponent. And now I can multiply this, and that would be 5 over x to the fourth. This is 5 over 1. And you just multiply the top, multiply the bottom. And you multiply fractions. Don't cross multiply. That's when you have an equal sign between them. But just multiplying fractions, just multiply top, multiply bottom. That's it. Here we see a 5x is the whole base. So 5 is part of the base. So if I reciprocal 5x, it becomes 1 over 5x raised to the positive exponent of 2. And that can be simplified a little bit further to become 25x squared, because I can square 5 and square x. Let's keep going here. A reciprocal of this is going to be 1 over 3x to the third. And now it's raised to a positive 2. So whatever the base is, again, I can put it over 1, flip this upside down, change the sign, and then simplify further. So squaring everything in here is going to be 9x to the, remember, exponent raised by an exponent, we multiply. 3 times 2, 6. All right, it starts to get a little bit more complicated here. These look more complicated. So again, follow the rules. Regardless of, I know I have a negative exponent in there. Now, when it comes to these, there's a lot of different paths you can go. What should I do first? There's not really a right or wrong answer. I guess there's always a wrong answer, but there's different things you could do first. Here, I would just pretend this is all one base, just like we've been doing. And because it has a negative exponent, we're going to flip it. So make it 1 over. And this stuff is still what it was. These things don't change. They're just now on the bottom. What changes is that that exponent is now positive. And let's see, we can go a lot further with this, because now if I distribute the exponent in here, exponent raised by exponent, multiply, that becomes x to the 3 raised to the fourth is 12. Y, we have negative 2 raised to the fourth, which is negative 8. And lastly, I don't want this negative exponent, so because this has a negative exponent, I could reciprocal this. And basically, when it comes to fractions, reciprocaling something is putting it on the other side. So the final answer here is y to the positive 8 goes back on top, where x to the 12th stays on the bottom. That's the final answer. Do it on time, about 8 minutes. All right, let's do a couple more here. Maybe we won't do all of them. We'll see where we are when we do a few more. All right, here what happens, from the last lesson, we know that when we divide a common base, we subtract. So 5 divided by 5 is x to the 0. And 2 minus 4 is y to the negative second. Now, what does this turn into? Well, x to the 0 is 1 times y to the second. So this is basically just gone, disappears, because it's times 1. And y to the negative second is 1 over y squared, because it has a negative exponent. We reciprocal it. And I put this example here just to kind of show you why these properties do. Y is something to the 0, 1. Y is a negative exponent reciprocal, because I think most of you would solve this differently. You would just say, all right, I cross these out, because it's the same thing. Anything divided by itself is 1. Well, yeah, exactly. It's 1, because you would end up with a 0 exponent, and that's why it equals 1, because anything divided by itself is 1. And here you may say, all right, I got 2 y's on top, 4 on the bottom. So when I cross out, 2 here and 2 here, I'm left with 2 on the bottom. That's because you're left with 2 on the bottom, because if you subtract, you have a negative amount, which means you have to have 2 left on the bottom. So that's kind of where these properties come from. All right, one more example here, and I'll check the clock, and if we're past 10 minutes, I'll skip that last one. So let's try this one here. Negative exponent, reciprocal of the base. So y goes to the top, 2x to the fifth goes to the bottom. And that whole thing is now being raised to a positive 2 exponent. Apply that to the top and the bottom. Y to the second is y squared. The bottom, 2 squared is 4, x, and x to the fifth raised to the second exponent raised by exponent is multiplied. Final answer there. Quick check of the time. Past 10 minutes, so I'll skip that last one. If you want, why don't you try that one on your own? And we can check our answer together in class if you have me in class. If not, good luck. And the next video here, as I mentioned, I think already is, this is video 2.2. The next one is going to be 2.4. There is no video for 2.3. All right, that's it. That's it.